Hey, 7th graders! Yesterday we looked at our first part of probability in this new unit. Today we're going to look more at chance experiments with equally likely outcomes and then calculating the probabilities for those. So, what are the possible outcomes in the following situations? If you flip a coin, you can get heads or tails. If you draw a colored cube from a bag that has red, blue, yellow, green, well, you can draw red, blue, yellow, or green. Picking a letter from, this should be from, not form, from the word classroom. Well, you have a C, L, A. You have two S's, but you would only list that once. You have two O's, you'd only list it once, so then R, O, and M. Okay? So an outcome is the result of a single observation of an experiment. The sample space of an experiment is the set of all possible outcomes of that experiment. So these would be the sample space. What are all the possible outcomes? The outcomes of an experiment are equally likely to occur when the probability of each outcome is equal. So, in the following example, suppose a bag of crayons contains 10 green, 10 red, 10 yellow, 10 orange, and 10 purple crayons. If one crayon is selected from the bag and the color is noted, the outcome is the color that is chosen. The sample space will be the colors, green, red, yellow, orange, and purple. Each color is equally likely to be selected because each color has the same chance of being chosen. There's 10 of each of them. Okay, next. So the numbers 1 through 10 are written on note cards and placed in a bag. One card will be drawn from the bag at random. List the sample space. Well, you could draw any number from 1 to 10. Are the events selecting an even number and selecting an odd number equally likely? Well, how many odd numbers do we have? 1, 3, 5, 7, 9. How many even? 2, 4, 6, 8, 10. So yes, they are equally likely because there are 5 even and 5 odd. Are the events selecting a number divisible by 3 and selecting a number divisible by 5 equally likely? Well, how many are divisible by 5? 10 and 5, that's it. Divisible by 3, we have 9, 6, and 3. So no, they are not equally likely because 3 numbers are divisible by 3 and only 2 divisible by 5. Okay? All right, another one. An experiment consisted of flipping a nickel and a dime. The first step is finding the theoretical probability of obtaining a heads on the nickel and a heads on the dime is to list, this should be the first step in finding, is to list the sample space. Okay, so here's all our options if we would flip a nickel and a dime. You can get heads and heads, heads and tails, tails and heads, and tails and tails. Okay, so what is the probability of flipping 2 heads? Equally likely, 1/4 for each outcome. So there's 4 options. So the probability of 2 heads is 1/4, or P 2 heads equals 1/4. Okay, your assignment is to complete the modal questions for lessons 3 and 4. Let me know if you have any questions. Similar to yesterday's assignment, there will be some questions that ask you to list the sample space, and then whether or not it's equally likely, or a specific one is equally likely, and that'll be about it. Let me know if you have questions, and have a wonderful rest of your day.